Hey everybody, this is JJ here with another Maya tutorial. Today I'd like to talk about triplanar mapping. If you haven't heard of it, triplanar mapping is a very useful technique to basically work with your models with a UV-less workflow. If you don't like doing UVs and you do need to do offline rendering, you can use this technique in a variety of ways. You can also implement this technique in other applications as well. But today I'm going to show you how to do it in Maya, Viewport 2.0, and Arnold. This is not going to be an exhaustive tutorial. There's many ways you can try and utilize this technique, but I will show you the basics and I will show you kind of how to work with it with a separate node so that you can interactively adjust the scale of your textures. Okay, so let's talk a little bit about what I got in my scene, what's going on with it. Basically, I built this little brick wall here with a cement kind of overhang feature. You can see that it's using, this is all in Viewport 2.0, so it's using some fun textures with the standard surface shader that comes with Maya 2020. I will save a copy of this scene and make it available in the link in the description of this video. So if you would like to download this as an ASCII file, you can download it and try it in your version of Maya and kind of tinker around, see how it works, and hopefully you'll get something out of this tutorial. So basically, I've got this brick wall here, and if you take a look at these UVs, they are complete garbage. Let's have a look. These are my UVs for this wonderful pattern here. You can even see how the tile pattern is represented. It really is awful. I mean, it's just not properly oriented or unwrapped at all. Now, if I go and show you what this looks like with a regular non-triplanar shading network, you can see here's the brick and here is the concrete. You have lots of stretching, lots of really bad looking artifacts in your image, and it's obviously never going to work, right? Well, here comes triplanar mapping. So I'm going to go ahead and unhide these spheres here to sort of demonstrate how triplanar mapping works. Now, if you take a look here, we have two spheres, and both of these are using the same material subset. One is a surface shader, and one is using the standard surface in Maya 2020. But this one is using triplanar, and this one is not. This one is using standard UVs. Now, when you build a sphere in Maya using a primitive, it generates a sawtooth pattern in the UVs. You can see that sawtooth pattern like that. It does this sort of jigsaw thing along the poles of the sphere, and you can kind of recognize how that looks just like that. And in your textures, it sort of shows up. You can see that pinching that occurs at the poles, and that's because of that UV pattern that's happening. With triplanar, however, that doesn't occur. And that's because triplanar will essentially draw a cube around your object, and it will project a texture along all 6 sides of your object, and then it will try to blend them, usually with a variable. In the case of Arnold, it uses a blend variable. It will blend those materials together, or those sides together, to give you a result that feels pretty seamless. And basically it works with pretty much any surface. Now, the nice thing about this too is that it's very dynamic. So I'm gonna go ahead and hide these and show you kind of how dynamic this can be. So because it's a constant projection and it's working in the background at all times and it's not UV dependent, you can manipulate your model to create all sorts of effects, and it will just continue to draw. It will always try to maintain the integrity of that triplanar mapping technique. So let's say I wanted to do something like push out this brick pattern and give it a little bit more depth. I can go ahead and add some edge loops where I see the pattern, and as long as I don't mess with the tiling of the pattern, I can go ahead and do some extrusions, and I can actually make this pop out and utilize it. Now, I've got some bevels on there, so you can see how that's kind of not working in this case, but I can obviously go through and just kind of, I can adjust that however necessary. So like if I took this part right here, and let's say instead we actually grabbed all those faces because I neglected to grab one or two faces. You can see how this can really work well. And so that's a pretty useful technique to kind of achieving some interesting results quickly without having to worry about your UVs. Okay, so now let's pretend that you actually you want to change the tiling pattern. You want to kind of get a better sense of scale, or maybe you need more resolution out of your texture, and so you need to make the tile smaller so that way you have more tiles. Well, in this technique that I'm going to show you guys, there is these things called place 3D texture nodes, and you can use these to drive the three-dimensional matrix of your position data, and basically you can use it for scale, rotate, all that good stuff. So I'm going to go ahead and select this and show you what happens when I move it. I'm moving it in one dimension. If I move it in all dimensions, you can see how it'll work. Now, of course, it's going to mess up my model here as far as the projection is concerned, but it's pretty cool. You can move stuff around. It might work better if you dial it in, you know, up here using these, because depending on how large scale your scene is, it will play a role in how effectively, or rather just how fast it will move, or how small the gizmo is. So if I zoom into the gizmo, you can see the gizmo is very small. And that's because my scene is pretty large. My scene is actually at human scale, and my unit scale is pretty small. So that would be why everything looks tiny when I'm trying to use these gizmos. But if I were to show you what it looks like, go ahead and make this clip plane smaller so you can see it. There you go. That's what it looks like. Okay, so if I rotate this, you'll see different results. If I scale this, you'll see different results. And this is how you would get more bricks or less bricks, larger bricks or smaller bricks. You could find whatever desirable pattern that you want. And this is a really great way to work if you're trying to dynamically adjust what you're doing. Now, this technique will also work with Arnold. However, because of the way Arnold's triplanar works, it has to do a unit conversion, which means you may not end up with the exact same pattern. So it might take some back and forth in order to ensure that your patterns are registered correctly. Mainly because and I'll show you how this one works in Arnold here. Let me see. I go to concrete, boop, and I go to brick, boop, and we'll go ahead and turn off these Maya lights, and we'll go ahead and turn on the Arnold light. Give it just a second. Okay. Now, you can't trust what this is doing in the viewport because it's an Arnold shader. It's designed to be rendered. So if I go ahead and hit this render button right here, let me make sure my settings aren't out of control, insane. Okay, they're not. If I hit this render button, you'll see it'll translate the scene and it'll process the render. And you can see how it works with an Arnold shader. Now, there's a few things to note about displacement and how Arnold works. I know we're not talking about displacement too much, but I wanted to test triplanar with displacement just to make sure everything functioned correctly. And every renderer is a little different. Every renderer is going to handle displacement a little differently. But if you notice my topology on this object, I've got a lot of geometry here. There's a lot of this really isn't necessary. However, if you want to do displacement, what displacement does when it goes to the compiler and it tries to displace the object, it subdivides the object as many times as it can, you know, basically just cutting it up into fours as often as it can in order to achieve that minor level of detail. So if there's not enough topology, or if you have really long rectangles or things like that, it will not appropriately subdivide, and you will see less detail in your displacement, or it just simply won't look nice. And there's a lot of reasons for that. And so generally speaking, if you're going to do displacement, I recommend modeling your objects so that you have very equidistant quads all along your surface, and you find your pinch points and make sure that you've got supporting edge loops to create those pinch points. As you can see, I've got a nice support loop here and here, which pinches this corner, and you get a nice solid corner that you would expect. But because these are just regular quads and they don't have any support edges, you can actually see how this one gets really rounded and this one here does not. This one is sharp here, but it's not sharp along this edge here because, again, there's no support loops. So if you're going to do displacement, I highly recommend making sure that you tessellate or subdivide your mesh enough, or manually add in whatever you need to add in order to do this. So as you can see, it does work pretty well. It's a nice little technique, and I'm going to now show you how to kind of set it up so you can get a good idea as to how to do it in your own projects. All right, so let's go ahead and close this. I'm going to go ahead and go back to my regular lights here, and we'll go ahead and go back to our regular materials. Okay, so one thing I like to do when working, if I'm doing work from home, or if I'm working on a remote machine, or if I need to work on a single monitor, is I like to split screen my Maya so that it's easier to use the Hypershade. Now the Hypershade by default, it comes with all sorts of stuff. The Hypershade by default typically has the property editor, and that's usually on the side here. And then it also has this lovely material viewer. And this is kind of how it defaults with the way Maya ships. But if you're really familiar with it, you can actually do a lot of other stuff. You can hit tab while you're in here, and you can type in the nodes you want, and it'll give you what you want. Very similar to something like Unreal Engine, if you're familiar with that, or the shader effects node network in Maya, or other different node networks. You can access stuff the same. So in order to maximize my space here, I'm actually just going to close the bins and close this. And that way I have all this real estate. And I'm going to take this Hypershade and I'm going to go ahead and dock it on the side here. So that way it takes up half my screen. And I'm going to take this Maya instance and I'll go ahead and dock it on the other side. And another thing you can do, I'm going to go ahead and turn off ambient occlusion and the super sampling, the anti-aliasing, and I'm going to hit Control Spacebar. If you hit Control Spacebar, what it does is it actually maximizes your viewport here, so you can actually see everything you're doing, and you can work like this. So now we have a full screen here and a whole lot of room here, and we can actually work pretty cleanly in Maya while we're doing our shading. So what I've currently got going on in here is I've got an Arnold shader, two Arnold shaders, and I've got two standard surface shaders, which are kind of like dumbed down Arnold shaders that work really well with Maya's viewport. And then I've got two surface shaders, which are basically the easiest things to process because they're just plain colors that get applied to your scene, and they do not have triplanar associated with them. So I'm going to go ahead and show you the Brick SS material. And you can select the material, then hit this input output connections to map it. And you can see kind of what we've got going on here. We've got our textures, and we've got these place 3D nodes here. I'm actually going to delete these. We don't need these. For some reason they decided to stick around. And we've got basically one texture, place 2D texture node that governs all of these textures. So if I go ahead and hit Control A, I can get my property, my attribute editor for this object. I'm going to go ahead and hit that repeat UV, and you can take a look at the screen, and you'll see that what it does is it tiles everything we've got. It'll tile it that amount. So this is another way you can adjust your triplanar projections. This is basically just how you repeat your texture patterns in Maya, is you use this place 2D texture node. And so this still kind of operates correctly. And what I've done here is I've taken all of these materials, all of these different textures, and I've piped this one node to rule them all into all of these texture nodes. So that way you don't have to go through each one and be like, double click, okay, change it, double click, okay, change it. No, we just have one node to rule them all. So in order to do that, you just go ahead and select in here, you go place 2D texture node, place 2D texture, and then you can literally say out UV and you can just pipe it into any one of these. And that's a super easy way to have it. Also, if you have your textures handy, you can actually go through and you can take your textures and you can literally drag and drop them in. And this is a super useful way to get your textures in your scene and kind of have everything you need to just fire away and get it started. So that is something that I highly recommend you do as well. Okay, so now on to the actual reason I'm making this tutorial, right? Okay, we've got these textures, we've got all this stuff set up, and basically what has to happen is you have to pipe those textures into a projection node, and then that projection node can go into your according channel, whatever channel you need. So in this case, I've got a color and an ambient occlusion piped into a layered texture, and you can see how this is sort of working, where the mixed ambient occlusion is on top and it is multiplied over the color, and it gives us, you know, a little extra out of our color there. And then you can see how that out color is piped into a projection. So if I type tab projection, you'll get that same node. And this projection node is actually a default Maya node. It's been around for a while. I don't know how long Triplanar has been around, but it is it's super handy that they included it now in here. And you've got different kinds of projection types in here. You can use this for all sorts of techniques, including things like camera projection. If you were trying to do something like match a camera plate to some 3D and you're trying to give it some depth, you can certainly use it for this kind of thing. But Triplanar is on this drop down here. So with this selected, go ahead and go to your attribute editor and find Triplanar. And then you can just go ahead and pipe your color or whatever object it is into the image and the out color into whatever out color scenario you need. Now, what you'll see happen is with different nodes, you get different results. So in the case of the normal map, you actually have to pipe it in a tiny bit different. And I'm trying to show all of these different catches, so I apologize if you guys already know this, but for those that don't, I'm trying to cover everything. So some nodes will just pipe directly in. Some nodes you need extra stuff in order for it to work. Now the Maya default shading network requires things like this right here, a bump 2D node. And you'll see the difference when we show the Arnold node later, but generally speaking, you have this bump 2D node, you out normal it, and you go to that normal camera, and you'll see it process, and now you have bump mapping on your wall. Now that doesn't always play nice, but that's the gist of it. So in this case, we need to take this normal map, and we need to pipe it into this bump mapping channel under the geometry group. So what we're going to do is I'm going to go ahead and break connection on this right click break connection, and I'm going to drag and drop this normal map with the material selected, middle mouse, drag drop onto bump mapping. You can see the slot highlight, and now it generates a bump 2D texture node. Now by default, this bump 2D texture node will be listed as a bump map. You have to switch that to a tangent space normal map in order for it to read correctly. Also, right now we're not using the projection. If I piped this projection into the normal camera, the bump mapping slot, it wouldn't have generated this node, which is what we need for this normal map to behave correctly. So basically, I'm just using this by middle mouse dragging it onto the geometry slot. I'm using that just to generate this, and that's it. I can basically delete the connection here, and I can take my projection, which is currently already piped in, out color, and pipe that into here. Now you'll notice that it doesn't let me do it. Well, why doesn't it let me do that? That's because Maya's default shaders are kind of antiquated, and there's some things that work and some things that don't work. And it's kind of silly, but just bear with me here. The Arnold one will make a little bit more sense, but because Maya can be Maya sometimes, there's just certain things that you know work when you've worked with the program long enough. So I'm gonna go ahead and double click this, the bump 2D node, and we wanna pipe it into that bump value. So I'm gonna middle mouse, drag that projection onto bump value, and it's gonna open this thing called the connection editor. This is gonna be very important later, but generally speaking, we wanna take that out alpha and we wanna pipe it into that bump value. There it is. Close. And now the projection is working correctly. Now the next thing is we have this place 3D texture node. Now if we do the tab and we say place 3D, you'll find that place 3D texture node. And this is going to serve as our wonderful, wonderful node that we were talking about earlier. Basically the thing that lets you govern your tiling, your movement, all that stuff. And what this is basically just a 3D coordinate system. It just tells your triplanar what point in space is it being used. And that's it. That's really all it's doing. But it's really nice because if you wanted to manually adjust it and have a kind of visual indicator of what's happening, this is just so much easier to work with. Now, unfortunately, there's not an easy way to do this when working in Maya to try and make sure that these things talk to each other. So you can see in my original one, which I have here, there's this output called matrix, and it's piped into this nondescript node right here. So the easiest way that I know how to do this, that I've been learning on my own, is to take this matrix, drag and drop it onto that orange circle. It's going to say other, and you hit other. And then from there, you can actually select what that is linked to, and it'll link it to that projection matrix. And essentially what you're going to do at the end of the day is you're going to pipe that same projection matrix into every channel. So that way, the roughness channel is using that same place 3D texture node. So let's try this again. We'll pipe this into here, other, and we'll say placement matrix. And now they all work together. So we have this one 3D place 3D node piped into the projection for bump, the projection for color, which is my color and my mixed ambient occlusion, and projection for roughness. And that's all the main nodes that I'm using for this brick in the Maya viewport. And so that one thing can now be moved around, it can be scaled, and we can actually have the result that we are looking for there. Now I still have my 5x5 tile. I can probably go back into this and we can remove this back down to 1x1. And that'll ensure that we're getting kind of a one-to-one representation of what we're talking about here. So it's the same story with the Arnold shader. The difference being in the Arnold shader, you're going to have to use a few different nodes. You want to use Arnold nodes, and a lot of the Arnold nodes start with this AI. So you have AI triplanar, you have AI normal map. Now that whole bump map nonsense that we had to deal with the Maya bump 2D texture node, we don't really have to deal with that with the Arnold architecture. If you just click tab, you can type in AIN, and you should find it right in that list, the AI normal map. And then you can basically take your normal map, pipe it into this AI triplanar, and then pipe that into your AI normal map. And then you can pipe that into your normal camera. And that'll give you the normal map for that. Now you can see in a lot of these, you can kind of see where that unit conversion has started to take place, where it adds a unit conversion when piping into this triplanar to make sure that it properly moves everything around, which means you're not going to see the same representations. So if I drag this onto here, and then I drag the concrete onto here, And we'll go ahead and disable our lights, our Maya lights, and we'll enable our Arnold light. We can do a couple of different things in order to view the updated results inside of our window here. If you go to Renderer, the nice thing about the latest versions of Maya is Arnold comes really pre-packaged and built in. It's very convenient. So if you just go to Renderer Arnold, what it will do is it'll bring up this little button right here, this little menu, and you can actually IPR, interactive preview, render your scene right here in the viewport. So you can still make adjustments to the camera and all sorts of stuff on the fly while you can view an update to your scene. And that can be very, very, very useful. Now, I don't have the fastest computer, so I'll try and make the best use of this as best I can, but all you have to do is hit that, and now you can kind of orbit around, and it will progressively update as you work. And if I wanted to change the scale, using that same exact node, I can go through and I can mess with the scale. Now I can do it in the viewport. You can see how it's working. The bricks are getting tinier and tinier and tinier. Or I can go the other way. Make them larger. And that will have its own impact on certain things. And you can actually see that one of the things that is happening right now is that our maps are not aligned up. We actually are seeing that the bump is not correlating to, and the displacement is not correlating to the physical tiling that's occurring here. And that's because I'm actually missing that same messaging network for the Place 3D node on this triplanar. I'm also missing it on the displacement. So if I go to this here and we look at the displacement, so you can find displacement easily by just selecting the shading group and hitting input output connections, because sometimes it likes to hide. It also generates a node up here in the material editor that forces that sort of displacement from happening here. So we got this one here. It looks like it's talking to it, but they're not playing nice together yet. So let's go ahead and try and make this work. Now this is where the connection editor is really important. So go to Windows, General Editor, Connection Editor. And this little thing has been around forever. This is as old as Maya pretty much. And basically what it does is it says you want to take this attribute and make it connect to this attribute. So you want to take the value from the out color, and you want that value to drive another value over here. And so in this case, what we're going to do is we're going to say place brick 3D, reload left. We're going to take the output of that and we're going to pipe it into the triplanar for the normal maps. And we're going to basically drive it a little bit differently than the last one. So the last one, there was a nice, position matrix, and it was super easy to just click the one thing. Well, it's not as friendly with Arnold. So in order to do this, you have to actually select the translate, rotate, scale, and line them up. So in this case, we have scale, and then we'll line it up with the scale. So what we're doing is we're linking the triplanar scale with the scale of our Place 3D texture node. Now we'll do the same thing with rotate. You can see it's trying to do conversions and all that good stuff. And translate, offset. And so now all of those things are connected with this particular Place 3D texture node. Now to do the same thing with the displacement, let's have a look and see what these two are doing. Maybe we missed one. So we'll go General Connection Editor. Okay, General Connection Editor. And then we will reload that. That's already there. So now we'll load this triplanar. Reload right. And we will go ahead and try and make sure that these line up together. Let's go ahead and see what's happening here. So translate should go to offset, rotate should go to rotate, scale should go to scale. So yeah, they're working. Let's see if it updates. And it did update. So sometimes Maya, you just gotta wiggle it a little bit and it'll come back to life. It's not always cut and dry, especially when you're dealing with a lot of displacement. Displacement in particular can be very, very tricky and annoying. But as you can see, our system is working. We can now control the brick layout with this. And it's a super useful, clean, easy way to work. So once again, just to review, keep it simple here. To select your material, you just go to your Hypershade, select the material, hit Input Output Connections, and you can review your nodes. In my case, I have a color and a mixed ambient occlusion piped into a layered texture node. And then the mixed ambient occlusion is multiplied over the color at 50%. That's piped into the triplanar. The triplanar is then piped into the base color. And then I have the same thing with the roughness map. The roughness map is piped into triplanar, which is piped into specular roughness. And the same thing again with the normal map, which is piped into the triplanar, which is piped into the AI normal map because this is an Arnold shader. And that out value goes to the normal camera. I have one place 2D texture node, which governs the entire texture set by piping the out UV into the UV coordinates. And then I have this place 3D texture node to govern the scale, position, and rotation of the brick pattern in Arnold and in Maya's viewport. I'm using the same nodes to govern both. And that's pretty much it, guys. Thank you very much for checking out this tutorial. I hope it was informative and helpful for you guys. If you have any questions, please go ahead and leave your comments in the comment thread below, and I'll try and answer them as best as I can. I'd like for this entire channel to really be a place of learning, and so the whole objective is really to help people grow as artists. And that includes myself. I'm always learning. I'm always trying to get better and learn different techniques for different ways of doing things. And so I want to share that because I think that's the best way for everyone to learn and grow, is if we share knowledge. So if you enjoyed this kind of video, or if you like this kind of content and you want to help support me, I do have a Patreon. I'll put the link in the description as well. And also I'll put this project file in there. Please give it a look and check it out if that's something you're interested in, helping me to do my different projects, as well as make more tutorials and free models and content like that. Thank you very much, and I hope you all have a wonderful night.